Hello, everybody. It's my pleasure to present my works on 3D concrete printing. Today, my presentation topic is 3D concrete printing towards digital construction. My name is Weng Yiwei, the Assistant Professor at Building and Real Estate, Hong Kong Polytechnic University. This is the outline for today's presentation. Firstly, I will talk about why we need to have 3D concrete printing to advance the conventional construction industry. Then we will further talk about how to do the 3D concrete printing. After these two sections, we will further talk about what's the challenges and what's the future about the 3D concrete printing. So before we talk about why we need to have the 3D concrete printing, firstly, we need to understand what's the limitations in the conventional construction industry. Basically, we know that in the conventional construction industry, we need to have a lot of workers working on site. And normally, the on-site working condition is quite harsh, which may result in many issues, such as safety issues. In US 2019, the construction industry contributes to 21% fatal injuries with respect to the total number of fatal injuries among various areas. The same trend can be found in Singapore. In Singapore 2019, the construction industry contributes to 30% of fatal injuries, which is also the highest number among these various areas. So this kind of high safety issues in the construction industry requires us to develop new technology to improve the safety of the construction industry. Apart from the safety issue, another issue regarding the conventional construction industry is the high labor intensive but low productivity. In Singapore 2018, we can find that the manufacturing industry and the construction industry has almost the same manpower requirement, which are 13% and 12% respectively. But you can find that the manufacturing industry contributes to around 22% GDP, which is 7 times higher compared with that of the construction industry. So from this, we can find that the manufacturing has much higher productivity compared with that of the construction industry. This is mainly because the manufacturing industry has adopted many new techniques to advance its productivity, such as digital fabrication. In response to the challenges on the safety and productivity, the construction industry keep on evolution. From the original methods, we call it conventional methods. In these methods, we need to have many laborers to work on site. Then they will work on the casting work, assembling work, and disassembling work, and so on and so forth. To improve the conventional methods, the precast concrete has been proposed. In this method, some construction elements can be built in the factory. Then these elements will be further transported to the construction site for the assembly purpose. After that, the prefabricated pre-furnished volumetric construction methods, or we also call it PVC. In this method, much more complicated construction component elements can be produced in the factory, such as the house unit. They can be produced in the factory and then transported to the on-site for the assembly. And finally, they can produce the whole building. And now 3D concrete printing is coming. 3D concrete printing will print the whole buildings in one go. So why this technology has great potential to further advance the conventional construction industry? So firstly, we need to understand what's the benefits of the 3D concrete printing. To have a better understanding on the benefits of 3D concrete printing, we can refer to this video. This is a prefabricated bathroom unit, which was completed at NTU 2 years ago. Basically, we can find that in the printing process, the whole PBU can be printed without the formwork, which indicates the cost incurred by the formwork usage can be reduced. At the same time, you can find that in the printing process, the materials will be deposited accurately. So it can help us to reduce the material wasted in the construction process. At the same time, in the printing process, we only need several levers to monitor the material mixing process and also the robotics manipulation process. So in this case, we can reduce the safety issues in the construction industry, and also we can make the working environment for the construction workers to be better. Additionally, you can find that in the printing process, we can produce this kind of complex shape structures. Normally, this kind of shape is very difficult to be produced by the conventional construction industry. This is mainly because the high cost incurred by the formwork manufacturing. Apart from these advantages, we have done an economical, environmental, and productivity assessment regarding the printed and precast PBU. Then the results indicate that regarding to all these aspects, the printed PBU can outperform the precast one. So from this, we can find that the 3D concrete printing has great potential to further advance the conventional construction industry. And that's why in recent years, more and more researchers are involved in these areas. You can find the trend of the publication output in last decades. The publications in the 3D concrete printing area has increased rapidly, especially in last 4-6 years. The exponential increase regarding the publication output can be found. Apart from the research works in this area, more and more large-scale construction applications have been implemented in recent years, especially in recent 10 years, you can find from this figure here. So now if you search online regarding the 3D concrete printing large-scale applications, you will find many this kind of large-scale printed structures. For example, in the USA, you can find this kind of printed house. In the Switzerland, you can find this kind of printed columns with complex structure. Then in the Singapore, you can find the printed house, which can be used for the residential house. So now we can understand that the 3D concrete printing has developed very fast in recent years and has greater potential to advance the conventional construction industry. So next, let's see how can we do the 3D concrete printing. 3D concrete printing was invented by the Professor Koshinevis at the University of Southern California. Initially, this technique was called contour crafting, which means we use this kind of gantry system to print the contour of the house. And then the concrete materials will be poured inside this formwork. Finally, we can produce the whole buildings. But now in recent years, more and more researchers refer this technique as 3D concrete printing, because this kind of method is a type of the layer by layer method. So researchers are much more prefer to use the 3D concrete printing as the name of this technique. In the 3D concrete printing process, normally we have 3 phases. In the production phase, we need to mix the materials. We will have the dry mix and also the wet mix to ensure the material can have sufficient performance for the concrete printing process. So once the material is ready, in the second phase, pumping phase, the material will be conveyed by the pump to the nozzle tip for the concrete printing process. Then in the third phase, printing phase, the concrete print will control the nozzle to move around and deposit the concrete materials to produce the final shape of the structure according to the designed 3D model. Then in the first phase, we need to have the certain materials which can be used for the concrete printing. Then in the second and third phase, we need to have the printing system to ensure the material can be delivered and can be printed. Then you can also find that in the printing phase, we need to have the very special devices, which is nozzle, which can help to shape the materials. And also we can design some special functional nozzle to achieve some special purpose. So as we mentioned in the previous slides, in the first step, we need to have the printable materials, which is the printable material mixing process is just similar like the conventional materials. We need to mix all the powders together. Then we can add the water, and also sometimes we need to add some additives in the materials to ensure the material can satisfy the requirements regarding the pumpability, placeability, and buildability. The pumpable means the concrete materials must be delivered by the pumping system. The placeable material means once the material is printed out from the nozzle system, they should can maintain their shape and to be placed. So we know that in the concrete printing process, it's a layer top layer manner. So which means the material need to have sufficient strength to support further layers materials. All these requirements regarding these three aspects requires us to design the materials very carefully. So we can use some supplementary cementitious materials and chemical additives to modify the material rheological performance to ensure the material rheological performance can satisfy the requirements. So once the material can have the satisfied rheological performance, they will be used for the printing. In the printing process, the rheological performance can ensure the material can satisfy requirements regarding the pumpability and the buildability. And finally, the materials can be used to print a high rise, maybe some high structural components and so on and so forth. So in the first step, we need to have the printable materials. Once the material is ready, in the second step, we need to have the printing system. Normally, we can use this kind of gantry system to print the materials. Gantry system is a type of the frame structure, just like this. Then the nozzle will be controlled by the crane, just like here. Then we also need to have the pumping system to convey the materials, and the material will be conveyed to the nozzle tip for the printing process. But the main limitation for the gantry system is that the printing area is limited by the frame structure here. So to avoid the limitation of the gantry system, the robotic system is further proposed. For the robotics printer, we can mount the robot to some mobile platform. So in this scenario, the concrete printing process can be done in a much bigger area compared with the gantry system, because the platform can move around and to carry the robotics arm to do the printing process. So in this case, more flexibility of the concrete printing process can be achieved. So with the printable materials and the printing system, we can achieve the concrete printing process. But in some cases, if we want to achieve some special functional materials, we can further design the nozzle system for this purpose. Basically, if you search online, you can find many different types of nozzle system which can be used in the concrete printing process. But in this presentation, we will just take several examples for the explanation. The first one I want to talk about is the geometrical shape control nozzle. We know that in the concrete printing process, if we just use some rectangular nozzle, maybe just like this, when the material is printed out from this nozzle system, we will find this kind of jagged surface. This is mainly because the material deformation happens. The material deformation is caused by the material, maybe they don't have the sufficient strength to support itself, or the weight of the higher layers materials will apply more loading or more force to the bottom layer materials and cause the material deformation. So to offset this kind of deformation of materials, we can design this kind of special nozzle to control the shape of the printed filament, just like this. We can introduce this kind of sliding plates to the nozzle system, then in the printing process, the sliding plates can change their position and to further change the shape of the printed filaments, and so that the final structure can achieve better surface finish. Another type of nozzle is a chemical or a mixture mixing nozzle, just like this. You can find that for this kind of nozzle, basically they will have two flow channels. One is for the concrete materials, another one is for the chemical additives, such as the accelerator. Then these two types of materials can be mixed at the nozzle head. Then final materials can have higher dosages of the chemical additives such as the accelerator. And then finally, the materials can have faster setting performance, and as a result, the material can have better buildability. So with the printable materials printing system and some special nozzle system, we can do a lot of interesting things in the concrete printing technique process. For example, we can use the 3D concrete printing to print the concrete tree and reception table. We can find that the concrete tree is a type of the modular printed structure. In the printing process of concrete tree, each segment will be printed separately. When all these segments were printed, they will be assembled together and to produce the final shape of the concrete tree. The reception table printing process is quite different from the concrete tree. The reception table is printed in one go, which means we design the reception table in the certain software. Then after we obtain the machine code for the concrete printing process, the whole structure will be printed at one time. Apart from this, we can also use the 3D concrete printing process to print the bridge. This is the bridge which has been printed by the TUE Netherlands. After the different models have been printed, they were assembled together, and also the pre-stressed steel reinforcement was introduced into this structure to enhance its safety and load-bearing capacity. Also, concrete printing process has been adopted to produce this kind of columns with very complex structures. These columns were designed by the computational design methods. Then they were printed by the 3D concrete printing process. After the formwork was printed, the steel reinforcement was introduced into this formwork system, and then the concrete materials will be poured inside this formwork system to further enhance its durability and mechanical performance. At the same time, the 3D concrete printing also can be adopted for some practical applications for our residential house, just like this. This house is printed by the TUE Netherlands just this year. So just now we talk about the benefits and also how to do the 3D concrete printing. And next, let's talk about several challenges in this area. Just as we mentioned before, for the printable materials, we need to optimize the material performance to ensure they can have sufficient pumpable, placeable, and buildable properties. Basically, all these properties are highly related to the material rheological performance, or we can see yield stress. But we know that the material yield stress will change with time, which is because of the materialization process. So the first challenge in the concrete printing process is to build the model to link the material rheological performance with the buildability performance of the concrete materials. So in this case, a model was built to correlate the relationship between the material property and also the printed height of the materials. To achieve the materials with different rheological performance, the different gradation methods was adopted in the material mixing process. We are using the continuous gradation, the uniform gradation, and the gap gradation, and also the natural zero set for the material mixing. And then we measure the material rheological performance. Basically, you can find that they will have different rheological performance with respect to the material yield stress. Then to further validate this model, we design this kind of the hollow column structures to do the printing process. Then in the printing process, it will print, the concrete printer will be adopted to print the whole structure, and then the maximum height will be recorded to indicate the printed height of the materials regarding to this kind of structure. Then you can find that this model can have very well prediction regarding the relationship between the material performance and the maximum printed height. Another challenges in the 3D concrete printing is about the interface issue. We know that the concrete printing process is a type of layer atop layer manner. Then because of this kind of unique construction process, the weak interface may be a big challenges for this technique. Just like this is a 3D printed concrete wall. Then we are using the tiles to form this kind of water pool, just like this. Then the water will be poured in this area. So in the test, you can find that the water can directly penetrate through this concrete wall system. This is mainly because the weak interface in the printing structure. Then why the interface will be weak? So let's go to this. The weak interface is mainly caused by the time interval between layers. For example, when we print a small structure by the 3D concrete printing, it will start from this point. This is the starting point. Then for the small structure, it will take around 5 seconds to reach the same point as the second layer. Then the 5 seconds we define as the time interval between layers. For the small structure, maybe the time is quite short, maybe several seconds, that we can finish the 1 layer printing. But if we print certain large structures, just like this, the time interval between layers can be as long as several minutes. With the increase of time interval between layers, it will affect the mechanical performance between interface, just like this. You can find that with increase of time interval, the mechanical performance, especially the direct tensile stress, will decrease. Apart from the mechanical performance, also the porosity between the interface, just like this, with increase of the time interval, then the porosity between interface also increases. So that's why the interface will be a big challenge in this area. To address the interface issue, we further design a nozzle system which can deposit the bonding agent between the interface. Then the bonding agent can help to enhance the bond performance of the final printed structure. This kind of printing scheme, we call it concurrent concrete and bonding agent deposition scheme. This is the design prototype of the nozzle system. You can find that for this nozzle, we have 2 flow channels. One is for the concrete flow process, the another one is for the bonding agent flowing process. Once the bonding agent reach the nozzle head, the rotational funnel will be adopted to receive all this bonding agent. Then they will be conveyed to the outlet of this rotational funnel, and finally they will be deposited just atop the previous concrete layer. This is the prototype of the design nozzle. 2 flow channels, one for concrete, another one for the bonding agent, rotational funnel, and it can be used to receive the bonding agent. This is the printing system we are used for the experimental part. We have 2 delivery systems. One is for the concrete, we call it a concrete pump. We also have another pumping system, which is for the bonding agent. Then in the experiment part, we are using the cement paste with 0.4 water to cement ratio as the bonding agent to enhance the bond performance. And the time interval between the interface is 40 minutes. So in this case, firstly, you can find that this is results regarding the mechanical performance. With the introduction of cement paste between interface, the bond strength is increased very slightly. This is because the cement paste cannot be evenly dispersed at the interface. And also in some cases, the cement paste will incur some big pores at the interface. To address this issue, we further redesign our nozzle system. This is original nozzle system, just like this. Then in the modified nozzle design, a spreader was attached to the nozzle head. Then the same experiment was conducted. Just here is the results. You can find that with the adoption of the spreader to the nozzle system, the bounce rate can be increased as high as 250% compared with that of the reference group. This is mainly because when the spread was adopted to the nozzle system, the cement paste can be evenly dispersed at the interface, and finally, the cement paste can act as an effective bonding agent between interface to enhance the bond performance. Next, in order to validate whether all these methods can be used for the practical application, we have done a large scale printing test with this model, and this 3D model has this kind of dimension. The whole printing test took 30 minutes. So from this large scale printing test, we can understand that our nozzle has great potential to be used in the practical applications to address the weak interface issue in the concrete printing process. The next challenge I want to further talk about is how to integrate beam with 3D concrete printing. We know that a beam is a very powerful technique to digitalize the 3D construction industry. Then how to integrate a beam with 3D concrete printing is a very interesting topic for us to explore. So in this preliminary work, we have done some works to integrate a beam with 3D concrete printing, especially for the printing press generation. We know that normally in the 3D concrete printing process, firstly, we will design the 3D model, then the 3D model will be converted into STL file, and then the slicing will be adopted to generate the printing paths and also the machine code, and finally, they will be sent for the concrete printing process. In the traditional methods, these two steps will be conducted in the CAD software, such as SolidWorks. We can design the CAD model in the SolidWorks, then we convert this kind of model into STL file. After that, the STL file will be further transported into the slicing software. Then in the slicing software, we will further do these 3 steps to produce the machine code for 3D concrete printing. Then in our proposed approach, we want to achieve all these steps in the BIM software, such as Revit, which means we can just design the CAD model in the Revit, and then finally we can directly obtain the machine code for the concrete printing process. So this is the developer's plugin in the Revit for the concrete printing pass generation. We know that in the Revit, we can design the BIM model, something like just like this. We can have the brick wall, the concrete floor, and also the concrete wall. Then in the user interface of the 3D concrete printing pass, we can define which kind of material we want to print. For example, we want to print a concrete wall, then you can just input the concrete wall here. At the same time, we can input the print speed, the layer height, extrusion width, density of infill, and so on and so forth, all these parameters which are required for the concrete printing process. Then this plugin can automatically detect the concrete wall in the Revit, and then generate this kind of the continuous printing path for the concrete printing. After that, we also have done the large scale printing test to validate our methods. You can find that this is a CAD model designed in the Revit. Then the printing path will be generated for the concrete printing process. So this is the final printing structure of our products. Basically, you can find that our methods can be used for the printing path generation in the 3D concrete printing process. So just now I have mentioned several challenges in the 3D concrete printing process. Now I want to further make a summary regarding the future challenges in these areas. For example, for the printable materials at the fresher stage, we need to further optimize material rheological and static to ensure the material can satisfy the requirements regarding the permeability and buildability. For the hardener performance of the printed materials, we need to optimize material mechanical performance to ensure it can satisfy requirements for the mechanical application and also the durability. Also, we should to further tailor material interface performance. And then the material can have better water permeability performance and to ensure the durability of final printed structures. At the same time, we can design some special device to control the geometrical accuracy of final printed structure. At the same time, we also need to put more efforts to develop a much more advanced system to further enhance the automation of the concrete printing process. Apart from this, we also need to find out the proper methods to integrate beam, LCA, design technique into the concrete printing process to increase the possibility of this technique in the future. Then in the future, what we can do by using the 3D concrete printing. This is just a perspective about the next generation of digital construction. We can design the 3D CAD model into the beam platform. In some cases, we can use some special design techniques such as computational parametric design and topological optimization to design certain functional structures. And then this kind of functional structures will be sent to the process simulation by using the virtual equipment. So once the customer is satisfied with this kind of the design and also the simulation indicates the structure can be constructed by certain methods, then the designed model will be sent for the real production by maybe 3D concrete printing. Once the whole structure is ready, the sensor system will be incorporated into final structures to collect the data. Then this data can be fed back to the beam platform for the construction management and the life cycle assessment, and also the management. By using this kind of closed loop production process, we can achieve the smart buildings and digital technology, digital construction in the future. So finally, I want to acknowledge the NTU, SEMCORP, Chip and Son, and National Research Foundation because almost all the presentation content is based on my PhD work. So I want to acknowledge these institutes and also the company first. At the same time, I want to further acknowledge the Hong Kong Polytechnic University and the University Grants Committee. They are providing the funding for my future research in this area. In the future, we will buy a serious equipment for the research in the 3D concrete printing area. Now we already have a KUKA robotics at the lab for the large scale printing. This one is a type of the fixed printing equipment. Then we will further purchase a small scale robotics and also a mobile platform. By using this set of the equipment, we can do more research related to the mobile concrete printing process, something like this. Apart from the printing system, we also will buy some material testing equipment and also the pumping system and also the material mixing system. And last, I want to further introduce my research team. Now I have 4 research staff at my research teams. One research fellow and Weng joined a PhD and 2 research assistants. Junhong will work on the printed materials. Yuji also will work on the printed materials. Tenfei will work on the beam and 3D concrete printing, and Dusong will work on the robotics and 3D concrete printing. Also, I have one more position available, which is regarding the research fellow. So please feel free to contact me if you were interested in this position. This is my contact info. You can just send me email regarding your inquiry or the applications. Okay, thank you.